Okay, so after we covered everything there is to know about JavaScript, we're going to start looking into taking a deeper look into some features of the language. And like every good course that starts with hello world, the second thing you do is explore the different variables and types that the language has to offer, the built-in ones at least. The reason is that because you cannot do anything without them, because that's what computers try to do. So computers just take data and try to process it most of the time. When they don't play porn, computers are used for processing data. Porn is also, by the way, form of data processing, because without it we wouldn't have videos. So in pretty much every program that you're going to write in every language, including JavaScript, you'll be doing some processing of data, of numbers, of strings, of text, whatever you use. So this is the basic structure of defining variables in JavaScript. We have the var keyword, then we have a name, and then we have some kind of value which we may or may not assign to your variable. That's we'll see more examples of this, of course. Data types. Important to understand what data types are. When we put a variable like this one, we actually allocate a part of the memory in our program's context, and we put some value into it. When we allocate some memory, we need to know how much, what's the size of the memory we need to allocate, and also how the program will interact with it. So for example, here we are defining a variable, and it's a number, and the value is 5. But unlike other languages like C#, for example, these things are very flimsy and loosely coupled when it comes to JavaScript, because you can make different variables hold different types at different times. So it could be a bit confusing. It doesn't mean that JavaScript is completely typeless. It has types. They're just hiding. So this is an example of how to allocate a number, which will have the number variable which will contain the number 5. So the basic data types that we're going to encounter, all kinds of numbers and strings mostly. So here we have a few examples of variables. The first one is a number which holds an integer value of 5. And down here we have another number which has a floating point number of 5.25. Basically all the numbers in JavaScript are floating point numbers, even if they're represented differently. We will see a little bit of tricks with numbers also later. But note that the first variable here, count, is first assigned to 5, and then it's assigned to the string hello. That's perfectly legal in JavaScript. In every other language, you'll have a compile time error. But with JavaScript, you can do whatever you want. Then we have another variable which holds a string, but this one is fine because it's not changing. Yeah. No. There is no int. Put the variable, just throw what you have, and that's it. There's only one keyword for defining variable. That's the word var. In C#, they came up with var pretty late. Before that, it didn't exist. But in JavaScript, the only variable definition keyword is var. And it doesn't mean that the variable isn't typeless, because of course there has to be a memory allocation, and there's some value that you're keeping. So there are types, and you can also determine what type the variable is. We'll see it later. But you cannot define in advance saying this is an int and this is locked. It's not strongly typed. So it's a bit tricky. And this statement, like I said, when you have a count of 5 and then count equals hello, is legal in JavaScript. Integer types. So basically, underlying 64-bit floating points are representing integers in JavaScript. There are some mathematical operations, especially bitwise operations that we'll talk about later, that actually take numbers and cut them down to 32 bits. But basically, all the numbers that are used in JavaScript are floating point numbers, even though they look like integers at some point. If you're assigning a variable to an integer, you know, integer is a whole number, right? It actually allocates a floating point number. So since they are since the data representation of integers in JavaScript, these are the two, this is the range of integers. It can go from -2 in the power of 53 to +2 in the power of 53. These are all the integers that it can support. We have these constants, number dot max safe integer and safe integer, minimum safe integer. These are numbers that are safe for calculations, and if you do calculations within this range, they should be okay and should give you a sufficient satisfactory result. Because, you know, computers, they're stupid, and when you do some things with numbers, sometimes they make mistakes because they're not accurate enough, because they have a limited amount of space where they need to perform numeric calculations. So if you are beyond the range of safe integers, you are responsible for your own result, and it will not end well. There's also max value, which is the biggest value that actually the language can support in a 64-bit number. So this is the number here. And there's min value. This is not the minimum number. It's not the smallest number that the language supports, but it's the biggest accuracy to 0 that actually a number can be. Like the smallest, tightest, closest to 0 that JavaScript can represent. So these are these two numbers here. So these are the range of integer numbers. Oh, there's a demo. Okay, let's take a look at it. First, the code. Not this one. So there is an external JavaScript file here called JS console, this one, and it comes with its own CSS, and we have a div on the page which is console. There are many demos which are built with those files in the background, and what it gives us is actually, if we look at the browser again, it's this black box into which we can write things comfortably with JavaScript. It's not something standard. It's something built for this demo. So then what we can do, we can call the method jsconsole.writeLine from this JavaScript code. If you want, we can take a look at it later, but it's not relevant. It just gives us a tool to be able to dump data to the screen as if it was a console. So for example, here we are writing to the console. Here we have a variable called student count and equal 5. And then we are writing here a string, and we are concatenating this variable to it. So when we look at it in the browser, oh, what the hell? Here's the output. So we can write lines like this. It gives us a way, a comfortable tool to seeing what's happening and what we're writing. So again, we have these variables again assigned. And what happens is that we're trying to calculate things out of the max integer. And you see what happens here. This number and this number, they look the same. Because once you exceed the max integer or the max integer range that we talked about, then you're on your own. And there are all kinds of oddities with calculations. I think we'll see a few more of those later, but that's basically what I wanted to talk about. Maybe in some points it will. Depends on your calculation. It's not safe. It's called the safe integer range, and if you exceed it, I don't know. It's a computer. They're crazy. Floating point types are more Well, like I mentioned, numbers in JavaScript, there's only one type. It's floating point types, but they are represented differently if you're assigning an integer, if you're using an integer like we did now. But basically, floating point types are the representation of number in floating point is more complex. I have a recorded lecture about floating point types and a whole blog post about it. So if you want to really understand how floating point types are represented in memory, there are different types of how a floating point number is constructed. But again, floating point types, it's the ones with the dot, you know, the decimal point numbers. And they can behave very badly. They depend on the implementation of on the memory allocation, on the OS, on the browser context, and those can behave in different contexts. They can behave badly as well, depending on what you try to do with them. So again, they have a range here, depending on the implementation. I'm not going to dive into how exactly they're constructed, but here's an example. Notice that what we have here is two variables that we're assigning 0.1 and 0.2, and we have 0.3, and we're trying to see here if this variable and this variable equals to this variable. And maybe, I think the next thing is to show it and see what happens. So first the code. So what we can see here is a few examples to floating point numbers. Math.py, as I mentioned, math is the mathematical library that allows you to do all kinds of mathematical functions and also contains all kinds of constants. So pi is one of them. I think you're supposed to say p. And we're printing it out to the screen. We have the number min value and max value. We'll see them in a second. We have a division by 0, which will give us math.infinity, or minus infinity if we're doing minus pi. And yeah, this is the example we saw in the slide. We have the minus 0.1, 0.2, and 0.3. And let's see what it looks like in the browser. Okay. So here is the pi. Here is the min value and the max value of the floating point numbers. If you divide by 0, you get infinity. If you divide a negative number by 0, you get minus infinity. If you try to do infinity divided by minus infinity, you get already completely crazy. So it says it's not even a number. The epsilon is the E number. And here we have 0.1, 0.2. But if we combine them, if we do this plus this, what we get here is an inaccuracy which comes from the way that floating point numbers are represented, and that could lead to errors. So you have to be very careful when you're dealing with floating point numbers. But you don't need this because you're not working in a financial company or something, so it's not relevant for you. You don't deal with numbers anyway. It's if you want to open. So like I said, if you want a bigger view at floating point numbers, you can go to this blog post, and there is a whole explanation of how floating point numbers are broken down and how they work up to the bit level, and there's a whole example. And also recording, which was done here in the academy at some point, about numerical systems and how they work and why these things sometimes fail to represent when you try to add something that looks trivial. Just know that it can be tricky. So numbers in JavaScript, there's only one object called number. There's only one data type called number, and numbers are double precision, meaning 64-bit floating points, like I mentioned. There are ways to convert numbers between different types, and there are various ways to achieve this. This is a common trick, and it's quite cool. You see here that we have a floating point 8.75. We take this number and we do a bitwise OR 0. It's a cool trick, but we haven't talked about bitwise operations. Basically, what happens is that bitwise operations work on 32 bits, so this number will be truncated into a 32-bit number, and when this is done, it actually gets converted to an integer. So this is a cool way, and it's actually quite performant if you want to perform it. It's performant if you want to do it, because it, I don't know why, but it is. So just remember that it is, but it's tricky because it can kill your numbers. So this is doing it again. So we're taking the number and we're adding in 0.5. So first we're incrementing it to 9 point something, and then we're doing a OR bitwise OR 0, and what we'll get is the whole part 9. Again, JavaScript is has sometimes can allow you to do many actions that you can't do in any other language so easily. So what we can see here is that we're taking a string and we're converting it into an integer. So what happens here is, again, we're doing this trick of bitwise OR 0. This will take the number and convert it into a 32-bit number, and then it will add 1. So we have two things happening here, two actions. I think, yeah, let's see this, and I think I have another demo or two to show on top of that. We saw this. Yeah, we saw this. No network. What I wanted to show also is this tool called JsFiddle. Yeah. You mean here? It will, let me think. I think it, I'm not sure if it will concatenate it or convert it to a number and then add 1. But since I just opened JsFiddle to show it also, because it's a cool tool, JsFiddle is one of the online tools that allow you to play with JavaScript. There's also another tool called Plunker, which is widely used. And there's also JSBin, but I like JsFiddle. It gives you a part with HTML, a part with CSS, a part with JavaScript, and you can immediately see your result. So, for example, let's take this. Oh no, what did I do? Put this here.